The human mind possesses a finite capacity for processing concurrent stressors. When an individual is faced with an impending high-stakes evaluation, such as a comprehensive
I have a
computer science
question.
What is
examination
it?
or a critical technical
How do I do
interview,
this?
the resulting cognitive load can rapidly become overwhelming. The data is clear. You are presented with 12 distinct topics, 37 discrete algorithms, and a mounting psychological state of panic that threatens to eclipse your entire history of documented progress. This acute anxiety is a natural, albeit profoundly counterproductive, cognitive response to perceived threat. Now, consider an alternative cognitive scenario. You activate your workstation, you parse a complex problem statement, and your cognitive architecture immediately begins constructing an optimal solution, outpacing the physical movement of your cursor. This state is not characterized by physiological stress, nor by the cognitive paralysis often termed freezing. Instead, it is a demonstration of pure, precise logical application and processing velocity. This is the state of flow, or automaticity, often observed in experts. The source material provocatively labels this the illegal way to study the discipline. From a psychological perspective, this framing is, of course, motivational hyperbole. There is
And just
nothing
like that,
illicit
the
about
handcuffs
cognitive
are broken.
efficiency.
Freedom
However, the underlying
achieved.
premise is valid. Once an individual masters these structured methodologies, their performance baseline is permanently elevated. They transition from a state of novice struggle to one of procedural mastery. Let us analyze this system. Let us first diagnose the perceived difficulty of computer science. Why does this field so often feel insurmountable? The perceived impossibility stems from its unique cognitive blend. It demands the simultaneous mastery of multiple, often conflicting, modes of thought. First, it
Here's how our
requires
system
navigating
works.
highly abstract concepts, networked structures like graphs, or the asymptotic analysis of complexity, known as Big O notation. Second, it mandates extreme precision regarding syntactical rules. A single misplaced semicolon, for example, can trigger
And that's the
catastrophic
missing
failure in
piece.
the entire logical construct. Third, the discipline relies on problem-solving patterns that, to the uninitiated, appear arcane or intuitive, almost like magic. Finally, it demands rigorous system-level thinking, an architecture where minor, localized errors can cascade and compound, leading to systemic failure. However, the critical insight, what the source calls a truth bomb, is this. Mastery in computer science is not, as commonly believed, a product of innate genius. Rather, it is the emergent property of two well-documented psychological processes: advanced pattern recognition and highly structured, deliberate practice. The human brain is not optimized for the brute force memorization of disconnected facts. Rote learning is inefficient and brittle. What is required is a superior cognitive system, a methodology designed specifically to transmute abstract concepts into reliable, automated instincts. We now examine this proposed advanced system. The first directive is a fundamental shift away from rote memorization. Step 1. Employ visualization, or what the text metaphorically calls code movies. The instruction is to cease attempts at memorization and instead engage in active simulation. You must learn to transmute abstract algorithms into dynamic visual narratives within your own mind. Let us analyze the provided example, the merge sort. Instead of memorizing its pseudocode, you visualize it strategically. Imagine the data array as a territory to be managed. It is recursively divided, as if by two opposing teams executing a battle plan, until each element is isolated. Each team, or recursive call, then sorts its own diminutive partition. The crucial merge phase is then visualized. Picture a conveyor belt or a zipper mechanism, which intelligently selects the smallest available element from the two sorted segments at every single step, methodically building the final, unified, sorted array. The psychological mechanism underpinning this technique is sound. Human cognition is evolutionarily optimized for remembering narrative sequences and visuospatial information. We retain stories and mental maps far more effectively than we retain dry, symbolic notations like pseudocode. By encoding the algorithm as a vivid mental scene, you are leveraging the brain's native architecture. This creates a durable mnemonic trace, making the concept stick with far greater reliability. Step 2. The prioritization of high-yield concepts, or
This
H.Y.C.
is what it usually
This is
looks
a
like,
pragmatic application of the Pareto
but we
principle.
want something
It is
like
a
this.
common cognitive distortion to assume all topics carry equal weight. This is demonstrably false. A strategic learner must triage information. The system suggests this hierarchy. First, focus on the core patterns, data structures like arrays, memory management concepts like pointers, the
We have
fundamental
three
logic
nested
of
boxes here,
recursion,
like
hashing
Russian dolls.
principles, the optimization technique of dynamic programming, and graph theory. Second, master the interview and exam classics. These are specific algorithmic patterns like the two-pointer technique, the sliding window, search algorithms
There's
such
the
as
bracket
depth-first
and
search,
all the dots.
DFS, and breadth-first search, BFS, various sorting algorithms, and advanced hashing applications. Third, understand the overriding system concepts. This includes complexity analysis, big O, memory architecture, the trade-offs between
And with that,
recursion and
we connect to
iteration,
box
and
B.
the principles of
This
API
shows an
design.
80%
The strategic
increase in
imperative
productivity.
is to allocate 80% of your cognitive resources to mastering these specific areas. All other peripheral topics should be treated as secondary seasoning. This focused allocation prevents cognitive diffusion and maximizes the return on study investment. Step 3. Trace, dry run, then code. Before engaging with the keyboard, you must first engage in manual tracing. This means you must literally, by hand, trace the algorithm's execution path. You will document variable states at each discrete step. You will draw visual representations of pointers and indices. You will predict the outputs for standard inputs and, critically, for edge cases. Why is this pre-computation necessary? Tracing is the mechanism that builds cognitive intuition. When you trace the logic first, the act of coding becomes a simple transcription of a validated mental script. The result is faster, cleaner implementation with a significantly reduced bug rate. Step 4. The construction of a pattern library. This is, in essence, the creation of a personalized knowledge base or lookup table. You are instructed to maintain a two-column cheat sheet. The left column documents the abstract problem type. For instance, find a subarray with a specific sum k. The right column documents the corresponding pattern or solution. For example, apply a sliding window technique or utilize prefix sums. Every new problem you encounter must result in one new line item. A critical mass is typically reached after 30 such problems. At this juncture, you will begin to perceive the underlying thematic structures. The objective shifts. You cease solving new problems, and you begin matching novel problems to established patterns, which is the hallmark of professional expertise. Step 5. Active recall paired with code flashcards. The psychological principle of active recall is non-negotiable for long-term retention. For computer science, this methodology is specific. Consider a flashcard. The front poses a high-level query. When should one utilize a trie? The back provides the answer, a summary of its use cases, its performance complexity, and a rapid visual sketch of the structure. These cards must be created for algorithm steps, complexity trade-offs, tricky edge cases, common syntactical errors, and even command line operations or Git flow procedures. Employing a system like Anki for spaced repetition will ensure this knowledge, both syntax and patterns, survives for months, not days. Step 6. The problem-solving pyramid. This is a protocol for graduated exposure. You must not skip levels. Skill must be built in sequential layers. Level 1. Read and comprehend solved examples. Understand the logical flow. Level 2. Engage with easy problems, which typically involve one or two patterns. Level 3. Progress to medium problems, which involve combined patterns and nuanced edge cases. Level 4. Only then attempt hard problems and optimization challenges, which require analyzing time versus space trade-offs. You must always respect this pyramid structure. Attempting to jump directly to level 4 is a common error. It is inefficient, wastes time, and is detrimental to psychological morale. Step 7. The 60-minute code sprint. This is also referred to as the 4x15 method. This technique utilizes focused, time-boxed sprints to build cognitive endurance under pressure. A 60-minute block is partitioned thus. 15 minutes are allocated for reading and planning, which includes tracing and pseudocode development. 25 minutes are allocated for implementation and local testing. 10 minutes are reserved for optimization and a formal complexity check. The final 10 minutes are for writing the final, clean solution, complete with professional comments. This regimen directly trains you to think, perform, and communicate clearly under pressure, mirroring the conditions of timed examinations and technical interviews.
Yes.
Step 8. Debug like a surgeon. It is a cognitive error to treat debugging as a punishment. It must be reframed as an integral part of the problem-solving discipline. When your implementation fails, the protocol is surgical.
Address the bugs.
Reliably reproduce the exact failing test case.
Write it down.
Second, print variable states, or preferably, use a debugger to inspect the program's internal state. Third, bisect the code. Comment out logical halves to isolate the precise location of the bug. Finally, after implementing the fix, you must write a new test case that specifically would have caught this bug, preventing future regressions. Step 9. Build micro-projects to apply and remember. Concepts must be applied immediately to be retained. Abstract knowledge is fleeting, applied. Knowledge becomes muscle memory. If you learn about hash maps, implement a miniature database. If you learn breadth-first search, build a tiny root finder. If you learn sorting algorithms, create a small visualizer that animates the process. These micro-projects serve to convert abstract logical patterns into durable, kinesthetic muscle memory. The synthesis of coding and building is what locks the knowledge in place. Step 10. Spaced repetition and mock interviews. This step combines retention with pressure proofing. A recommended schedule. On day 1, you learn the new topic and practice easy problems. On day 2, you perform active recall and engage with medium problems. On day 4, you simulate an examination, either through a mock interview or a timed test. On day 7, you conduct a final, rapid-fire review of the concept. Timed mock sessions must be conducted weekly. It is also critical to engage in at least one pair programming session or a formal mock interview with a peer to simulate the unique social and performance pressures of a real evaluation. Step 11. The CS Vault. This is your competitive edge, described as your weaponized study repository. This vault must contain short summaries in your own words for each critical algorithm, your comprehensive pattern cheat sheet, a log of common bugs and their precise fixes, a curated list of 20 go-to problems for each pattern tagged by type, the source code for your micro-projects, and, if possible, recordings of your mock interviews and the feedback you received. You must treat this repository as your centralized, strategic arsenal. It must be updated every single time you acquire a new piece of tactical knowledge.
These represent how
Step
we
12,
might feel inside,
the identity switch.
but sometimes
This is
we need
perhaps
to
the
push
most
past it.
critical psychological component of the entire system. It involves a deliberate cognitive
This
reframing
is
of your
just not
self-concept.
working.
You must cease the internal monologue of, I am bad at algorithms.
Sometimes my
This is a
mind
fixed
feels
mindset,
like a locked
and it is
box.
self-defeating. You must
But other
replace it with a
times,
growth mindset,
it's a growing
behavior-oriented
sprout.
statement, such as, I am a person who solves one new pattern every day. Bugs must be reframed as feedback, not as personal failure. You are a system builder, not a line memorizer. Your identity dictates your behavior and your persistence. Act like the engineer you intend to become, and the requisite behaviors will follow. We can also analyze the supplemental quick hacks through
You
this
see how
lens.
O goes directly
Memorizing
into my
big
head.
O cheat cards provides constant time recall for complexity analysis. Using templates for common scaffolds like input parsing or DFS reduces cognitive load. Renaming variables for clarity is a core principle. Clarity is the antidote to bugs. Committing solutions to GitHub with concise notes creates an invaluable revision archive.
Let's make sure
Using
everything
rubrics,
is in order.
correctness, complexity, edge cases, style, forces a structured self-assessment. You are psychologically closer to this goal than you perceive. While others engage in panicked, unstructured copy-pasting, you are building a robust cognitive system. One pattern, one sprint, and one vault entry at a time. Cognitive mastery often arrives much faster than most individuals expect. You are not merely cramming, you are engaging in the meta skill of engineering your own cognitive processes. The goal is to transform your mind into a coding machine, one that thinks, debugs, and constructs solutions with speed and precision. We invite you
Welcome
to
to the world of
contribute to the
ideas.
discussion. Which of these cognitive patterns are you focusing on this week? Are you mastering arrays, dynamic programming, graphs, or the logic of recursion? Please share your thoughts in the comments section below. If you found this analysis valuable, we encourage you to subscribe to the channel for future content.